Lesson 31 continues our topic with matrices, but now we're going to learn a couple new things that we did not learn in Algebra 2. So what we're going to learn today is called Gaussian elimination. So it's named after the mathematician Gauss, if you remember, who was the guy who added up the digits 1 through 100 when he was like little, like 10 years old. So he also came up with this, and this is a really useful way for solving systems of equations that have more than 3 equations. So in these first 2 examples, I only have 3 equations, and these are super simple systems of equations to solve because they're in what we call triangular form. So by triangular form, what I mean is that we have like an x, y, z, a y, z, and a z term. So it creates a triangle. Okay, and the reason these are so simple to solve is because we can look at the very last equation, in this case z equals 2, and we already have the first number, right? So we know z is equal to 2. So then I can plug into the second equation and get y plus 2 times 2 equals 7. So y plus 4 equals 7 means that y is equal to 3. And I can plug both of those into the first one and have x minus 2 times 3 plus 4 times 2 equals 3. So x minus 6 plus 8 equals 3. So I get x plus 2 equals 3, so x is equal to 1. So I have 3 numbers. I have x is 1, y is 3, and z is equal to 2. Okay, so the next one, if I have 2z equals 6, then I know z is equal to 3. And then I keep plugging in going backwards, right? So I'm going to plug into the next one. So negative y plus 3 times 3 equals 9. So negative y plus 9 equals 9 means that y is equal to 0. And I have x plus 2 times 0 plus 3 equals 7. So x plus 3 equals 7 means x is equal to 4. So I get 4, 0, 3. Okay, so obviously this section is not going to be about things that are in triangular form, right? We're going to be solving things that are much more complicated. And we're going to use something called Gaussian elimination. So Gaussian elimination, basically you're going to write a matrix without writing x, y, z, w, and so on. You're not going to write all of the variables. Very similar to when we learned long division, and then I taught you synthetic division, where we didn't write the x squared, x cubed, x to the 4th, and all of those. We just left the numbers in. So with synthetic division, we didn't write the variables and we divided. With Gaussian elimination, we're not going to write the variables and we're going to add and subtract rows, move them around, and so on. So there are 3 operations that yield an equivalent system. So basically, an equivalent system is a system with the same solutions as the original system. It just looks a little bit different. So we can add 2 rows together. That makes sense because you guys have seen like x minus 2y equals 4 and 2x minus, or we'll say plus 2y equals 10. We know that we can add straight down. So we've done this before. We can multiply one row by a scalar. So an example of that would be like if I had 2x minus y equals 8 and I wanted to multiply through to get like negative 3y, well, I could do that, right? I could multiply by a 3 and get 6x minus 3y equals 24. That's an equivalent equation. And we can switch the order of the rows. So I could write something on the top and then switch it to the bottom, right? So we're going to be doing those with a matrix. So example 1, I actually, I wanted it to be easier than the one that I gave you. So I want you to edit it. So maybe pause the video and write down the new example 1. So you should have 1x plus 3y minus 2z equals 0, 2x minus 4y plus z equals 10, and x plus 2y minus z equals 1. So I wanted to give you a simple one. The one that I gave you involved a lot of fractions. So, okay, so it says, I always follow these steps for Gaussian elimination. So I first interchanged rows to get it as close to triangular form as possible. So in our first example, we don't really have anything that makes it into triangular form, right? We have 3 equations and they all have x, y, and z. So we can't really get it in triangular form. If possible, get a 1 or 1x in the left-hand corner. So we're good. We actually have a 1x there. That's what we want. Okay, and what we're going to do is we're going to write it as what we call an augmented matrix. So we're just going to write the numbers and we're not going to write any of the x, y's, and z's. So I'm going to say 1, 3, and negative 2. But then I'm going to augment or add the coefficients on the right. So equals 0. So then I have 2, negative 4, and 1 equals 10. And I have 1, 2, and negative 1 equals 1. So that's what we call an augmented matrix. It's kind of like putting matrix A and matrix B from before together into one. So we're going to circle the term, and then we're going to look at the terms below it. Okay, so we're going to look at the 2x and the x. So we're going to multiply the 1, or the number in the top left, by a number to eliminate the number in the second row and third row below it. So I'm writing and third row in parentheses because we're actually going to do this step twice. We're going to eliminate the thing that's in the second row, and then we're going to eliminate the thing that's in the third row. So I always write my operations to the side. So what I want to do is I want to multiply 1x. If I multiplied it by a -2 and then added it to the second row, that would be what I want, right? That would allow me to get a 0x in that spot below the circled green part, right? So that's what I'm going to do. I'm going to do -2, and I'm going to multiply it by row 1, and I'm going to add it to row 2. Okay, so I'm going to go ahead and do that step. I'm not going to adjust row 1 at all. Row 1 stays exactly the same. So I have 1, 3, -2, and 0. But row 2 changes. So if you need to get a scrap piece of paper, that's fairly helpful when you're first doing these. Eventually, you'll be able to do them all in your head very, very quickly. But it can be difficult at first. So what we're doing is we're saying -2 times row 1 plus row 2. So we're multiplying row 1 by -2. So I'm going to get -2, -6, 4, and 0. And I'm going to add it to 2, -4, 1, and 10. And I'm going to write that result in the second row. So I'm going to have 0, -10, 5, and 10. Okay, and then I'm also, in the same step, I'm going to do the same thing to get rid of the row 3 term. I want to get rid of this number that was right here. So how do I do that? I multiply the first row. You're always using that first row to get rid of the 2 things below it. So I multiply my first row by -1, and then I add it to the existing row 3. So if I multiply the first row by -1, I'm going to get -1, -3, 2, and 0. And I'm adding it to the existing row 3, 1, 2, -1, and 1. Okay, so that's why I was saying you might need a, scrap piece of paper to do this. So we get a 0, we get -1, we get 1, and we get 1. Okay, so that's the first step of Gaussian elimination. So we have, you should now have, oops. One, 0, 0, like that. Okay, now what we're looking for is this term right here. We really, really want it to be a 1. Okay, in our case, it's not. It's a -10. So you could divide everything through by a -10, but when you do that, you're going to have a fraction. Do you guys see it? If you multiply by -10 here, here, and here, right here, you're going to get a fraction. Okay, so we want to avoid that if possible. So one thing we could do that might help us out is we could switch the row 2 and row 3. Okay, so I'm going to have 1, 3, -2, 0, and I'm going to switch these 2 rows. So I'm going to do 0, -1, 1, 1, and 0, -10, 5, and 10. And we really like for our numbers to be as small as possible, and like I said, we want this to be a 1, if possible. So what we're going to do is we're going to take this new row 2, and we're going to divide by -1. And since I said I want my rows as small as possible, I'm going to take my -10, 5, 10, and I'm going to divide through by -5. Okay, what I'm doing is this is negative, that last row is -10y plus 5z equals 10. That's what that's representing. So all I'm doing is I'm dividing through by -5 on both sides, which is totally legal. So the top stays the same, so I have 1, 3, -2, and 0. The second row I change by dividing by -1. So I get 1, -1, and -1. And then I divide the last one by -5, so I'm going to have 0, 2, -1, and -2. So be really careful. It can be hard sometimes with the numbers. It's a lot to do in your head. Okay. So now we're ready to eliminate Like we have the 1 here like we want, so that's good. And we want to get rid of the 3 and the 2. So it says circle the term with the second variable in the second equation and eliminate this variable in the equations below it. So I should actually say above and below. I put above and below it. So like you're eliminating everything except for that term. They're all going to be zeros. Okay, so since we're using row 2, we always want to do row 2 times a number added to row 1, row 2 times a number added to row 3. So let's think about this. If you have a 1 for row 2 and you want to get rid of that 3, you're going to have to take row 2 and you're going to multiply it by -3. And luckily, since you have zeros in those other 2 spots, it's not going to change the 1 that we already had in the upper left-hand corner. Okay, so I know it's a little confusing when you see this for the first time, so we're going to do a couple examples of this. So what I want to do is I want to make it so that the 1, 0, 0 stays the same. And then I get a 0 here and a 0 here. Okay, so I'm going to do one thing at a time. So I'm first going to do row 1. So what I'm going to do is I'm going to take row 2, and notice how you have a 1 there. I'm going to multiply it by a -3, and then add it to row 1, so that those 2 terms, these right here, eliminate each other. Okay, so I'm going to do -3 times row 2, and I'm going to add it to row 1. So again, if you need some scrap paper, here's what we're doing. -3 times row 2 makes 0, -3, 3, 3. Then I'm going to add it to row 1. So eventually you'll be able to do this all in your head. And when I do that, I get a 1, I get a 0, like I have written, and then I get a 1, and I get a 3. Row 2 stays exactly how it is. And then row 3, we're also going to adjust. So we want to get that we want that 2 to go away. So how do we do that? We take -2 times row 2 and add it to row 3. So we're going to do -2 times row 2. So I'm going to get 0, -2, 2, 2. And I'm going to add it to row 3, 0, 2, -1, -2. So when I do that, I get 0, 0, like I have, 0, 0. And then I'm going to get 1, 0. Okay, and this is what we want, because right here, that is like triangular form. Think about what that's saying. That's saying 0x plus 0y plus 1z equals 0. So we have now solved for z. Okay, and all of this is really in triangular form. But I want you to go a couple more steps until we get in row reduced form. You guys see how this is in triangular form because we have this triangle right here that would help us solve it. So if we wrote it with x's, y's, and z's, we'd get it right away. So we're going to go a bit further. And now what we're going to look for is a 1 right here. So if there was not a 1, so if it said 5 and 10, like that, then we would divide that row by 5. Okay. But we do have a 1 like we want. And now we're going to use this row to get zeros in the 2 spots above it. Okay, so in those spots there. Okay, so how do we do that? So we're going to take something times row 3 and add it to row 1. Okay, so what do we need to do? If we want to take this 1 and use it to get rid of this 1, we need to do -1 times row 3 and add it to row 1. Okay, so the bottom row stays the same. Everything that we've accomplished so far stays the same, like the 1, 0, 0, 1 parts. Only the numbers here are going to be different. Okay, so you can basically fill in almost all of it. Okay, so when I do -1 times row 3 plus row 1, think about what number goes here. So see if you can do it without writing down those steps, because that's our goal. You want to be able to do this without having to write it off to the side every single time. So if I have -1 times row 3, I'm going to get -1. Adding it to the 1, I get a 0, exactly like I wanted. -1 times 0 is 0. Added to 3 gives me 3. So what have I just found? I just found that x is equal to 3. And then I do the same thing for the second one. Now this one is just row 3 added to row 2 because it's already 1 and -1. So when we add the row 3 plus row 2, we get a 0 here, and then we get a -1. So what do we have? We have x is equal to 3, y is equal to -1, and z is equal to 0. And we have now solved the system. All right, so what we just did is we got something in row reduced echelon form. Okay, so I'll write that out, row reduced echelon form. And I'll show you how to do this on your calculator in a little bit, but you do need to definitely know how to do it by hand because, like I said, college classes are making you do this, and they make you do it without a calculator completely. So most college classes these days, Purdue, IU, IUPUI, don't even let you use a calculator. And if they do, then it's a basic calculator. It's one that just has sine, cosine, and tangent, but it doesn't have a graphing screen. Okay, so you need to know how to do this. And I will definitely put one of these on the non-calculator test. I'm not going to put a lot, but I'll put one. All right, so let's try the next one. And this one does get a little bit messy, if I remember from filling out the notes. So we are going to have a couple fractions. So don't get too worried if you have fractions. It could happen. I think I don't get fractions till the very end, though, so it's kind of nice. And I'll make it so it's nice on your test. I'm not going to give you really, really terrible ones. All right, so let's write it in the as an augmented matrix. So I have 1, 1, 1, 3, 4, 3, 4, 8, 9, 3, 4, 7. Okay, so we have what we want. We have a 1 in the upper left-hand corner. If that had been like the third equation, we would just rearrange our rows as needed. Okay, so we're good. And we want to get these two things to be zeros. Okay, so we have to use row 1 somehow. So we're always multiplying something by row 1 and adding to whatever row we want to change. So in this case, I'm going to do -4 times row 1, and I'm going to add it to row 2. So my row 1 stays the same. My row 2 changes. So you can write it out if you need to. So I'll do it on the first couple. So I'm going to have -4 times row 1, so -4, -4, -4, -12. And I'm going to add it to row 2. So 4, 3, 4, 8. When I do that, I get a 0, -1, 0, and -4. All right, on the next step, I want to get rid of that 9. So I'm going to multiply row 1 by -9 and add it to row 3. So again, if you need to see it, go ahead. -9, -9, -9, -27. I'm adding it to 9, 3, 4, 7. So I'm getting 0, -6, -5, and -20. Okay, I almost have the one that I want, right? I want a 1 right here next. But I have a -1. So what am I going to do? I'm going to take that row 2 and I'm going to divide by a -1. I also noticed that row 3 has a lot of negatives and I don't like a whole bunch of negatives, so I'm going to multiply out by a -1 as well. So I have 1, 1, 1, 3, 0, +1, 0, +4, 0, 6, 5, 20. So now I repeat the process. So I have a 1 where I want, so I'm going to use row 2 in order to get rid of the terms above and below it, okay? So I have to multiply something by row 2. So I'm going to say row 2 multiplied by -1 added to row, oops, not row 3, row 1. Now, as you're going, there's a lot of things that you can fill in already. So right now, I'm not changing row 2 at all. I'm changing row 1 and row 3. So I'm going to leave row 2 as it is. Okay, I'm also not going to mess up anything that I've done so far. So I'm still going to have my 1 and my 0. So as long as you're doing it correctly, those will remain unchanged. Okay, so when I do -1 times row 2, I'm going to have 0, -1, 0, -4. I guess I should have just left it, right? And then I have 1, 1, 1, 3. So when I add, I get 1, 0, 1, -1. All right, and on the next one, I want to get a 0 where the 6 is. So I'm going to multiply row 2 by -6, and I'm going to add it to row 3. So I'm going to have 0, -6, 0, -24, and I'm adding it to row 3, 0, 6, 5, 20. So I get 0, 0, like I wanted, 5, and -4. All right, so we pretty much have what z is. If you notice on the very last equation, this one, what this means is that 5z is equal to -4. So that means z is equal to -4/5. So we're going to do that step where we find z. So we want that to be a 1. So this is where we get the fractions, but it's okay because we're almost completely done. So we're taking row 3 and we're going to divide by 5. So I get 0, 0, 1, and I get -4/5. Did I say 5/4 before? I don't know what I said. So -4/5. All right, and then this one's actually what I want as well. I have a 0, 1, 0, so that's lucky, so we're good there. The only thing that I need that I don't have is I need a 0 here. I always want it to be like the identity matrix on the left side, the 1, 0, 0, 0, 1, 0, 0, 0, 1. So I need to use row 3 somehow to get that. So I'm going to take this, so let me leave it as it is, and I'll do one more step. I'm going to take this row 3 that I have, and I'm going to multiply it by -1 and add it to row 1. Everything else is going to stay the same because everything else is already as that identity matrix. So when I do that, if I take -1 times row 3, I have 0 times -1 is 0, added to 1, so I'm good. This is still a 0 like I want. This now becomes a 0. And then -1 times -4/5 is 4/5. Added to -1 becomes -1/5. So I have my 3 answers. I have x is equal to -1/5, y is equal to 4, and z is equal to -4/5. So I'm sure you guys are wondering, like, why do we do this? It's so much easier just to do by hand. But if you remember when you were in Algebra 2, I gave you guys these, and this was a really miserable assignment because a lot of people made mistakes, okay? And I'm not saying that you're not going to make mistakes with Gaussian elimination. It's just a little bit quicker if you don't have to write the x, y's, and z's all the time. And as you get used to it, it is a pretty quick method of solving, okay? So I know you don't like it, but it's something you got to get used to, I guess. All right, so these next ones, it says solve the system using Gaussian elimination or row-reduced echelon form. So after I do these ones with the calculator, I am going to go back to page 121, which we skipped previously, and I'm going to show you how to find an inverse of a 3×3 using Gaussian elimination. But for now, I'm going to show you how to solve using your calculator. So the fastest way to solve a matrix equation with your calculator is to use this row-reduced echelon form. So what we're going to do is we're going to go to second matrix. Oops. It always like shuts down when I already opened it up and now it's messing up again. All right, so let's go to, okay, I tried to do it now. Now I have 3 open and they're all saying the same thing. Okay, there we go. So we're going to do second matrix. And we want to edit matrix A. Okay, and we want for it to be one of these like adjoined matrices. What did I call it? The augmented matrix. Okay, so we want 3 rows and 4 columns. So it's going to be a 3. Whoops. Dang it. These are probably making fun of me. I do this all the time. 3×4. All right, and I'm going to put in everything that would make it an adjoined matrix, or an augmented matrix. So I'm going to have 1, enter, -2, enter. Maybe let me go back to the page and show you what I'm doing. So I'm putting this as the augmented matrix. So I'm going to have 1, -2, -1, 6, 2, 2, -1, 1, -1, -1, 2, and 1. I'm putting all of those numbers in. Okay, so I have 1, -2, -1, 6, 2, 2, -1, 1, -1, -1, 2, and 1. Okay. And then when I get out of here, so do second quit, if I go back into matrix and I go to math, there's lots of different things. So you could find the determinant, you could find, this is called the transpose, there's lots of different items. So you're going to go all the way down to where it says RREF. Okay, so mine it's option B, but you might check. So what this stands for is row reduced echelon form. So we're going to do row reduced echelon form of that matrix we just put in. So we're going to do second matrix A. So we select it. You can put a parenthesis. Oops. Dang it. You can put a parenthesis if you want. That's what just messed me up. So don't do a parenthesis, apparently. No, on this one it's just a little weird. So second matrix, math, row reduced echelon form, enter, and then matrix A, enter, and hit enter, and it gives it to you. Now, if there were decimals in here, you can even do your math, and you can change it to a fraction if you want to, but in ours, it was already nice numbers, right? So what we're getting is for that answer, I have 1x plus 0y plus 0z equals 3. So that means that x is equal to 3. And then the next equation, the next line is giving me y is equal to -2 and z is equal to 1. So those are my solutions. So I get x is equal to 3, y is equal to -2, and z is equal to 1. So on your test, if I asked you to do this, I would probably ask for you to show the setup. So 5, 2, 0, in this case 4, 3, 4, 2, 6, 7, 3, 4, 29, and then I would ask for the solutions. So our solutions for this next one, if you do this, should be 2, -3, and 6. All right, and then the same thing for number 3. So I went ahead and did this one. So 2, 1, 3, 3, -2, -1, 1, 5, 4, -2, 2, 2. And when I did my row reduced echelon form, I got -1, -1, and 2. And then I did not do this one, so I'll go ahead and do this one. So 2, 2, 3, 3, 1, 3, 2, 5. So these are definitely very, very easy test questions. But be careful, because a lot of people on their signs, they mess it up. Okay, so a lot of people will put in the wrong signs as they're going to their matrix. So we're going to do second matrix. We're going to edit. We can just edit right on top of this one. Okay, so I'm going to do 3, enter, 1, enter, 1, enter, 4, enter, 2, enter, 2, enter, 3, enter, 3, enter, 1, enter. Let's see, I would have just messed it up because I put a 2. So I need to do 1, enter, 3, enter, 2, enter, 5, enter. Hopefully that's the only one that I did 2 on. Okay, and then I'm going to do second quit to get out of here. Whoops, second quit. And I'm going to do my row reduced form. Now, if you've already done it, you can do second enter, clear, and I'm going to do second enter, and that will pull up the last thing I put. So as long as you're editing A, you can keep doing second enter. It will pull up the last thing that you had. Hit enter again. So it says that the answers are 1, 2, and -1. So very, very quick way of solving. Even easier than the A inverse times B thing, right? Okay, so now that you've done that, I know it looks like you're almost all the way done with the notes, but we skipped a couple in the last section because we did not know how to find the inverse of a 3 by 3. So I'm going to show you how to find the inverse of a 3 by 3 without using a calculator. So you will know how to do this like if it was on a non-calculator test. And what it does is it uses the row reduced echelon form. It uses Gaussian elimination. Okay, so if I have -3, -3, and -4, and then 2, and then all of this. So I'm going to write what A is. So remember, A is going to be -3, -3, -4, 0, 1, 1, 4, 3, 4. Okay, and I need to find A inverse. So the way that we find A inverse is we adjoin this matrix with the identity matrix. Okay, so if you remember, the identity matrix is the one with 1s down the main diagonal and 0s everywhere else. And what we want to do is this is A, and this is I. What we're going to do is we're going to switch it. So I will be over here, and this will end up being A inverse. So I didn't say that very clearly. We don't just switch them around. We use Gaussian elimination so that we get the identity matrix on the left-hand side. So we're basically doing the same process that we did before. We're trying to get this to be a 1. Whoops, I erased it. And once we get it to be a 1, then we can eliminate the things below it, and so on. Okay, so it's a little bit messy. Actually, this one's example number 2. Let me do example 1 first. It's a little bit easier. So I'm going to have 1, -1, 1, 3, 2, 0, 1, -2, 2, And then, like I said, I'm going to join that identity matrix. I realized I was doing example 2, which is a lot harder. So let's do the easier one first. Okay, so we have a 1 exactly where we want it. And we're going to get zeros in these 2 places. Okay, so I do that by saying -3 times row 1 added to row 2. So the first row is the same. This becomes a 0 as I want it to be. -3 times row 1, again, if you need to write. And then added to row 2. I said row 3 before, row 2, sorry. So I get 3, 2, 0, 0, 1, 0. So when I add, I get my 0 like I want. I get a 5 here. I get -3, -3, 1, and 0. All right, so now I want the last spot to be this one here to be a 0 as well. So I'm just going to do -1 times row 1 added to row 3. So let's see if we can do this in our hand. Basically, we're doing row 3 minus, or in our hand, in our head, we're taking row 3 and we're subtracting out row 1. So row 3 minus row 1 is going to give me 0. -2 minus a -1 is going to be -2 plus 1, so -1. 2 minus 1 is 1. 0 minus 1 is -1. 0 minus 0 is 0. 1 minus 0 is 1. Okay, and now we continue. So I want this spot to be a 1. Okay, so the easiest thing to do instead of dividing by 5 is to switch my rows. So I'm going to switch. But I'm also going to divide by a -1 as I do it. So I'm going to have 0, +1. Whoops, I'm going to run out of room if I write this big. So I'm going to have 0, +1, -1, +1, 0, -1. So I divided by -1 everything that was on row 3. And then row 2, I'm just going to move to the row 3 spot. And then row 1, I keep the same. Okay, so I got the 1 where I wanted it. Okay, so I'm going to take my row 2 and I'm going to multiply it by something to clear. So I'm going to say row 2, I don't multiply anything, I just add it to row 1. Oh, geez, I keep doing my little joined matrix. Okay, so I get my 1, 0, 0 like I want. This is going to be a 1 and this will be a 0. Okay, so when I add these rows, I get a 0 here as well, which is always good. And then I have a 2, 0, and -1. Second row is the same. All right, and then I'm going to do -5 times row 2 added to row 3. So I'm going to get a 0, 0 like I want. -5 times row 2 becomes 5, plus a -3 is 2. -5 times row 2 is -5, plus a -3 is -8. 0 plus 1 is 1. 5 plus 0 is 5. Okay, so I'm almost there. All right, now I want a 1 in this spot, so I'm going to divide everything by 2, and this is where we start to get the fractions. So row 3 divided by 2 is going to be 0, 0, 1, 1, and then -4, 1/2, 5/2. Give myself a little bit more room. All right, the top row is the same. That's what it was because we already have the 1, 0, 0 like we want. Remember, we're trying to get it to look like the identity. Okay, and the second row is temporarily the same, but we're going to use row 3 to change it on this next step. So we're going to say row 3, we don't need to multiply by anything, we just need to add it to row 2. And this will be our final step, and then it will be the identity matrix. So I'm going to have 1, 0, 0, and I'm going to have 0, 0, 1. So these rows are exactly the same as what they were. All right, so I'm going to get my 0, 1, 0 like I want. So when I do row 3 plus row 2, -4 plus 1 is -3. 1/2 plus 0 is 1/2. 5/2 plus 1 is 2.5 minus 1, so 3/2. So this matrix over here ends up being A inverse. Okay, so kind of crazy how that works. So hopefully you kind of understood those steps. You can always check, like you could go to your matrix on the calculator, and you could put in second matrix, and you could put in matrix A. Oops. That's fine, I'll skip it. Second matrix. Doesn't like it when I go away for a while. So you could put in matrix A. So 1, -1, 1, 3, 2, 0, 1, -2, 2, and then you could do A inverse like we did before, and you should get exactly the same thing. So you might want to check, but you should get exactly the same. So that's how we find an inverse of a 3 by 3, 4 by 4, and so on. So it's nice for a 2 by 2 that we have the formula, right? But we don't have formulas for all the other ones. We do it by using the inverse matrix. It's easier than memorizing crazy formulas, right? All right, so example 2. So we started it out. So we're going to do exactly the same thing. So we want to get this to be a 1. And as you can see, in order to do that, we're going to have fractions. Okay, so it's not going to be very fun. So we're going to divide this by -3. So I get 1, -1, 4/3, -1/3, 0, 0. And I have my 0, 1, 1, and this one stays the same, 4, 3, 4, 0, 0, 1, and so on. So I'm going to take my row 1, and I'm already good on row 2. Like that's already has a 0 where we want it. So we're good there at least. And my row 1 stays the same. So I'm going to multiply by -4, and I'm going to add it to row 3. So I'm going to get my 0. On this one, I probably will have to write it off to the side. So I have -4, 4, -16 over 3, 4 over 3, 0, and 0. And I'm going to add it to row 3, which is 4, 3, 4, 0, 0, 1. So I'm going to get 7, -16 over 3 plus 12 over 3. So -4 over 3, 4/3, 0, and 1. All right, so now we have a 1 where we want it to be here. So we're going to take row 2, and we're just going to add it to row 1, and then we're going to take row 2, and we're going to multiply it by -7 and add it to row 3. So row 2 is the same, 1, 0, 1, 1, 0, 1, 0, and we still will have our 1, 0, and our 0, 0 like we want, okay, if we do those operations. So I get row 2 plus row 1, so 4/3 plus 3/3 becomes 7/3. I have a -1/3, 1, and 0. And then here, -7 times row 2, so I'm going to have 28 over 3. Let me just write these out. So hang on, that's not 28 over 3. So even I will mess up on these occasionally. So I have 0, -7, -7, 0, -7, 0, and I'm adding it to row 3. So 0, 7, -4/3, 4/3, 0, and 1. So I'm going to have 0 and 0 like I want. So I'm going to have -21 over 3 plus -4 over 3, so -25 over 3. And then I'm going to have 4/3, -7, and 1. Okay, so like I said, it gets a little bit messy sometimes, so I won't give you a crazy one like this on your homework. It's just good to know and good practice before you guys do go to college. So then we're going to multiply by 3 over 25 on our R, well, -3 over 25 on our R3. So I'm going to get 0, 0, 1 like I want. And then I'm going to have, let's see, -3 over 25 times 4 over 3, cancel, cancel. So -4 over 25, -21 over 25, no wait, positive 21 over 25, and -3 over 25. I have 0, 1, 1, 1, 0, 7/3, almost there. All right, and our last step is to use that row 3. So I'm going to have row 3, and I'm going to multiply by -7/3 and add it to row 1. So I'm going to get my 1, 0, 0 like I want. The bottom row is still the same. All those lovely fractions. So let's see, so negative 3, 7 over 3 times row 3. So I got my 0, so let's see, so 28 over 75. This gets really, really messy, doesn't it? Wonder if I made a mistake. If I made a mistake and you find it, let me know. All right, so I have negative 7 over, I'm just going to look at these last couple numbers. So I'm going to have 28 over 75. I'm going to have 75, what is that, 147, and 21 over 75. And I'm adding it to row 1, which is negative 1/3, 1, and 0. Let's see, so I get 1 over 25. $74 over 25 and 21 over 75. Kind of messy. All right, and then I still need to do row 2, so I'm going to do, let's see, negative row 3 plus row 2. So those ones are actually kind of nice. So I'm going to have 0, 0, or 0, 1, 0. Oops. All right, and then I'm just going to have 4 over 25. 4 over 25, because that would be 25 over 25 minus 21 over 25, and then 3 over 25. Okay, so very, very messy, and now you see how insane these can get. So this is why I wanted to show you how it is without a calculator. I know that it's really, really messy. I did not make them that hard on MathExcel, and I will not make them that hard on the test, but you really do need to know it in order to pass pre-calc, because pre-calc is really the only thing you kind of need before you go to college, right? So I wanted to prepare you guys now. So that's the end of summer pre-calc. Are you excited? I hope so. Great job this semester.